Where are your notes?
Right here. Hey y'all, today's objective is rational numbers. And a rational number is a number that can be written as a ratio of two integers. Integers are positive or negative whole numbers. We're not talking about decimals in a fraction. And in this ratio, we're talking about two integers. The root word of rational is ratio, so that should make sense. A number that can be written as a ratio of integers. Some examples of rational numbers. Percents can be rational numbers, fractions, mixed numbers, and decimals. And so the decimal part of rational numbers could be repeating decimals or terminating decimals. Terminating decimals mean they end. For example, 1/4 is 25 hundredths. So that ends. That is a terminating decimal. A repeating decimal, like 1/3, is 0.3 repeating, 0.33333, it repeats. It is also rational because it can be written as a ratio 1:3, and this is a ratio 1:4. So if you can write the value of the number as a ratio, that makes it a rational number. Okay, example 1, express the fractions as decimals. This hopefully is review. I'm hoping I'm not teaching you something brand new. So we have the fraction 5/8. 5/8, it's a ratio of 5 to 8. And if you want to change a fraction to a decimal, you have to divide 5, the numerator, divided by 8, the denominator. 8 going into 5, hopefully you remember that you're going to have to add a decimal and a 0 because 8 cannot go into 5. That's what's going to make it a decimal. 8 will go into 50 how many times? 6. Subtract and we're left with 2. 8 will go into 20 2 times. That's 16. You subtract and you're left with 4. Bring down another 0. 8 will go into 40 5 times. 5 times 8 is 40. And the equivalent, the decimal equivalent is 0.625, 625 thousandths. Now, part B, -1 2/3 is a mixed number. If you have a whole number, you know that's going to be at the beginning of your decimal, -1, and then 2/3, we're going to divide to change that to a decimal. Your numerator will go inside, your denominator is going to go on the outside. Again, you add a decimal and a 0. This should not be new. 3 will go into 20 8 times, nope, 6 times. 6 times 3 is 18. Subtract and you're left with 2. You bring down a 0. 3 will go into 26 times, 18. Hopefully you see a pattern. It's going to be 0.6666 repeating. So we're just going to use bar notation, which is a bar over the repeating decimal. That's called bar notation. So -1 2/3 is -1.6 repeating. All right, so this last one, 3/4. I am hoping that you know 3/4 is a decimal off the top of your head. But in case you don't, you would divide. And I'm going to let you try that one. Pause it. You finish that one. Okay, press play. And 3/4 as a decimal is 75 hundredths. Think of 3/4, 75 cents, or 75%. So expressing the fraction as a decimal, you're going to divide the numerator divided by the denominator. Okay, example 2, express the decimals as fractions. Express the decimals as fractions. If you know how to correctly say the decimal, then that is pretty much the work for you. If you just know this as 0.45, then it might be difficult. But if you know this as 45 hundredths, then that's exactly what you write. 45 hundredths is 45 out of 100. 45 out of 100. If there's 2 decimal places, that means it's been divided by 100 because 100 has 2 zeros. So 45 out of 100. And then you always want to reduce or simplify. Always reduce and simplify. We'll divide by 5 and 9/20. And if you can, keep dividing, but we know that 9/20 is simplified. So now I have expressed my decimal as a fraction. Example B, 0.14 doesn't help you, but if you know that this is negative 14 hundredths, then you can go ahead. Don't forget your negative sign. You reduce, so you would divide them both by 2 because they're both even. And we would get negative 7/50. All right, this last one, you try C. Pause it. I want you to try it. All right, because you have a whole number, you know that you're going to have a mixed number as your answer. And then the 0.6 is 6/10. So reduce 6/10, divide them both by 2, and you get 3/5. So 5 3/5 is your final answer. That is how you change a decimal to a fraction. Again, I hope this is not new. This shouldn't be new, right? Goodness. Now this part might be new. All right. What are we at? 6 minutes. Express the repeating decimal as a fraction. If you have bar notation, then those are repeating decimals. And if you want to write those as fractions, there is a process for you to go through. It's not as simple as just saying 5/10, because this is not 5/10. 5/10 is just 0.5. This is 0.5555 repeating forever. So I'm going to show you how to change a repeating decimal as a fraction. I feel like this should be its own video lesson. So I might stop here. Okay, repeating decimals are rational because you can write them as fractions. That's why I need to show you how to write a repeating decimal as fractions, but I'm going to make this a separate video because it's going to be too long in this video. So skip that example, and we're going to go to example 4. Is the number rational? Is this value rational? So the answer is just going to be yes or no. Is this rational? A, 5.3 with the bar over it means 5.3 repeating. 5.3 repeating. And like we said in the beginning, any repeating decimal can be written as a fraction. And I don't know, maybe you know that 0.3 is 1/3. That would be nice if you knew that. So this is 5 1/3, which is rational. Any repeating decimal is rational. B, 2 1/2. Well, just like 5 1/3, this is a ratio that can be written. 2 times 2 is 4 plus 1. This is a ratio that can be written 5/2. So that, yes, this is rational. Example C, 0.112233 ... That means this goes on forever. But it's not repeating. 0.1122334455. So it's not repeating and it doesn't end. So this is not rational. Because it's not repeating and because it does not end, it is not rational. Letter D, this symbol is pi. I know you've heard about pi. I know you've seen pi. Pi, some of you even probably know many, many digits of pi. Pi is not rational because it doesn't repeat and it doesn't end. Negative 3/9, even though it's negative, it can still be rational. 3/9 is written as a fraction of integers, so yes, this is rational. And then example F, 0.375, 375 thousandths, that is a terminating, it ends, it does not have ... So yes, that is a rational number. So these are examples of rational numbers, and then C and D are not rational because they do not repeat and they do not end. So we will practice more with rational numbers in class.